lengthwise goes, okay? No, I didn't. Thought I said. I didn't say that, did I? No, but you know what I mean, though, right? For word count, if he gets hung up on something, yeah. Don't take it. Okay, let's do vector proof. Does somebody have that proof sheet handy? Does somebody have that black sheet handy? Nobody? Okay, well, I like it, okay?
We have a black sheet.
This one. You know, that black photocopy, this one here. Now, which one did I ask you? Tori, remember we were working through these, and there's one I said I would do on the. Remember which one it was? Was it 4 or 6 for one of those? Was it 4? Okay. So this is number 4. If you remember, this is when I was like frantically trying to rush through the unit, and I said I wouldn't have time to go through homework take up. So this is one of the days I didn't have time for homework take up. So this is number 4 off the black sheet, off the vector proof sheet. Okay. One other thing I should mention for this 1B you can ignore. I didn't talk about negative ratios, so there might be a question like that where you have the ratios. 1B will give. So number 4 says given parallelogram ABCD. Now, if you say I don't know how to draw a diagram, let me remind you. In order to draw a parallelogram, you have to start in the top left corner and go sort of around the circle. Okay. So I'm going A, B, C, D. Prove that the diagonals of the parallelogram bisect each other.
It doesn't matter which way you go, because I have A, B, C, D.
No, it'll just be harder to follow the notes when I do the example here today. So it says, let X be the midpoint of AC. Okay, so I have to show that Bx is equal to Xb. That's what I have to show in this question. Now this was given, all that was given to you, okay? So I know that that's the midpoint. I have to show the other two works out as well too. Okay, now for this question, what else do I know that I haven't told you if it's a parallelogram? There's a few other things that we know. Yeah, go ahead.
A, B, C.
Yeah, so I know that these two ones are the same. I'm going to do 2. What else do I know? Somebody else, what else do I know? Brad, go ahead, what else do I know? AB is equal to BC. All right. I don't want to take a stab at how I would, stay with me, Luke. I don't want to take a stab here what my first step is going to be. Trying to show that Bx equal to XD. Go ahead.
You're just changing them into the other.
Yeah, very good. So I want to show that these two are the same. I don't know. So what I'm going to do is I'm going to take XD. I'm going to try and write it in terms of Bx if I can. Okay, and hopefully then I'm going to hopefully cancel things out and life will be good. I'm hoping that. Okay. Is that the nicest way to do it though? There's probably an easier way to do it, to be honest. I was thinking of just breaking it like this, saying Bx is equal to XC plus CB. Whoops, that's on that side. That looks even better because I don't need to mess around with anything. Thank you, Bill. Okay, so what's another way I can write BC? What's equivalent to BC? AB. What's equivalent to CX? XA? XA. Okay, I'm going to rewrite these. So I have XA plus AD. What is XA plus AD equal? Yeah, you could have done the same thing, yeah, you could have done the same thing. So what's XA and AD equal to? XD. Before improvement.
Almost made no sense.
Almost made no sense?
Yeah.
Okay, let's talk, so let me slow down here, let me go through here, I know you weren't here, Brendan, let me just slow down here for a second, okay? So what I did was I started with this, I said, well, BX is this. Now, me as a math teacher, I was looking at this and I said, well, the reds are gonna be the same and these are gonna be the same, so let's write in terms of that. So I wrote BC plus CX. I could have chosen BA plus AX as well too, that would have worked the same way. Okay, so I knew that BC was equal to this, and this plus CX plus that, and it all worked out. That's the way it worked. I could have done the same thing. I could have said BA plus AX, and then I said, well, AX is equal to this plus this, and you would have gotten the same
But then
result.
you just sort of like assume that AX or XA and then AD just equals XD.
I didn't assume that's vector addition, right? If I say XA plus this, another way you can write that.
So
is
if
that.
it's in a triangle, then two sides equal one.
You're thinking way too deep with this, right? All I'm saying is, if I had this plus this for vectors, what's the result? Whoops, let's try that here. If I had this plus this, what's the result? Like this. Okay, so all I'm doing here is I'm adding what I had, XA, which is this, plus this. What's the result? Yeah, which happens to be XD. That's all I'm doing. Like you're thinking way too deep with this, right? It's just going to be I'm adding the different sides together,
Okay.
right? And because it's a parallelogram, I know that these things are the same in the other sense of entries with it. Okay, so what I did was I started with BX, and I said I can write that as BC plus CX. It's the same as that. Randy, the question? Go ahead.
I'm just confused when there's like when it's like in the assignment is like 4 at a time and all of the
Yeah, so for the assignment, I'm not going to give you the answer, okay? But the question was something like this. What was it, AMN or something? AM plus AN or something like that?
It was
Go with me, just okay, whatever, but let's stick with it. So all you do is this, you can distribute.
Could you like do it for both sides?
Yep. That's all I'm giving you guys for that one, okay?
it'll just be like longer.
What's that?
Yeah, I got just fine. It's just the same idea.
Yeah, so because the idea is this, because this is the thing that's tricky with this question. There's like, I think I got it backwards, but anyway, there's 12 things here and there's 6 things there, so you have to shrink them down somehow. And on this one, I think it's 9 and 8, I think is the way it works out. So there's one little trick that you have to do to get the last one. Yeah, yeah. Or you can come and lunch one day if you need to. That's what I recommend. We can go through something similar to it. Okay? All right. Did that sort of make sense what we did here? A little bit. You just have to think of the things that are equivalent. That's it. Yeah.
Okay, so since we did like the whole BC plus CX, could you like this as well, do BA plus AX?
Yeah. Don't we do it with BA plus AX?
Like, I just like to see a bunch of different things, and I like.
Yeah. BA plus AX would work. I can say that BX. I have to show that that's true, so I'm going to say BA plus AX. Okay, BA is equal to CD, right? AX is equal to XC. So XC plus CD.
To me, they're just
Right, so it worked the very same way, turn it out way too. All right, tension question? Or like a river question or something like that? You guys want a tension one or a river or a Superman or what's the question? Superman? Okay.
Like what you just wrote.
Okay, so let's slow down here, guys, please, 1 sec. Okay, so this part, you okay?
What's the difference between CD plus XC and XD?
Nothing.
Oh.
But the thing is, okay, if you do XC plus, CD plus XC would give you, that's not tip to tail, right? Because this plus this would be the vector way out there. You see what I mean? So what is it? CD plus XC would give you this vector out like this. Which technically is the same as this, but it's outside the diagram, right? You know what I mean? Like, because that's the thing, which is, like, that's the same as that, but it's not in your diagram. Right.
So basically, if I were to run this down, if we want to show that bx equals xt, and we just sort of like do it in a way that. Hang on. I get it. I get it. Okay.
Let's start with tension, then we'll do a, this is going to be a tension question. Okay. Tension is what's in the air and calculus fast today. That's what's in there. So we're going to say, oh, perfect. She's Spider-Man. What should we weigh? 65 kilograms? Who here, as an aside, who here is 18? Okay, I recommend seeing the Wolverine, the new Wolverine movie.
So you're saying people who are 17 can't watch it?
It's rated R. It's rated R.
I was gonna see it, but I was
It's rated R, so that's on.
yeah.
Okay, enough with that. Let's stay with superheroes. Okay, so all I'm saying is this: Spider-Man is swinging, is webbing himself like this. Okay, so his one arm is going like this, his other arm is going like this. His body is the only thing. The real question would say Spider-Man has a 1,000-kilogram car, you know, by his foot or something like that, they'd say, or whatever, okay? Spider-Man is 65 kilograms. If his left arm web is at 35 degrees to the wall, and his right web is 45 degrees to the wall, how much tension is in each web? This is one I want, if you get this question on your test, I want everyone in the class to be able to knock out of the park. Okay, this is one I want you guys to be able to dominate on. Luke, you can do it. Okay. I'm going to draw a diagram to make sure we get it, and then I'll let you guys do some calculations, okay? If you want to ignore me and just do it yourself, you may. I will not force you to listen to me at this point. This is the only time you'll ever chat with your teacher. Okay, so here's Spider-Man. Okay. I take it back. The force of Spider-Man. How do I figure out what Spider-Man's force is going to be? Now, I heard some people wondering about this today, how to calculate mass and all that stuff. This is not one of the automatic things. How do we calculate force? Fg equals mg. Okay, so it's the mass times gravity. So the mass of Spider-Man is going to be 65 times 9.81. Can someone please be brave and check the minute calculator for me? I'm going to pick on Jason because he's first on the draw for this one. 165. Okay, now I want to make sure that everyone understands tension questions. If Spider-Man's body is 635.65 newtons down, how much do his webs have to support? Newtons up. Okay, right? It has to be opposite. Okay, so when you add the components of these two, hint for the question, where I give you the tension, the components have to add to be the gravity, okay? All right, so I'm going to add these together. So Spider-Man's left arm, he's going to be facing the blackboard today, he's going to be. It doesn't matter, yours will just go opposite. So is it 35 degrees to the wall? And I call that T1. His right arm is going to be 45 degrees to the wall. And that's going to be T2. Are we feeling Austin cool, sort of okay about what's happening here? I want to make a cool joke, but
Wasn't that just a joke there?
no, it wasn't. I'm feeling better. I was feeling pretty down when this class started, but I'm still not better. Okay, so I have to add those two vectors together to get a vector up to balance 637.65. Are we all okay on the log for that? Okay. So I'm going to add T1. That's T1 to T2. And that is going to equal a vector of 637.65 newtons up. All right, I'm going to pause right there on the video. I want you guys to solve for that. Okay, get your angles in there properly. Okay, you guys can do this. You guys are a tremendously gifted and bright class. Remember that. Okay, don't put yourselves down. I know word problems are difficult. You guys can handle this. You can do this. Have confidence in yourselves, please. Your job is to put some angles in and then use sine law twice.